Okay, we're rolling. And we're back with the wheelchair, the two-wheeled wheelchair, but it's got a pendulum on the bottom to do the stability part, which is quite novel. Well, it is novel. Oh, and I steer well clear of it.
The program also knows all of the Z values that a new layer happens at. That comes from Jackson's adaptive program, which I still
It's just loading it up at the moment.
Yep.
So there's a little bit of resistance from the motors.
Yep. So this is our model in LabView. It's coming up.
Oh yeah, so sure.
So we use the second order slide remote control. This is our control panel, and this is our block diagram. So you can see here, we read the data of the pitch angle and pitch angle of velocity from that sensor, the red one, VN200. It's really.
Is that the MPU
No,
6050?
No, that one. The red one is VN200. It's one of the best IM sensor.
Okay.
We get the data of that one. And according to the dynamic modeling we developed here
I
for the
see.
system,
I see your serial
we
code.
calculate required torque, and we found also the torque constant because there is not any torque option control inside the VSC. So we transfer it to the current with using the torque constant, and we send it to the UR signal, and UR signal will be sent to the Arduino, and Arduino can control the motor controller.
Okay.
Yeah, it was really
That's all right.
complicated.
It's all right. You get
So
there.
we can run it.
Yeah.
So
I've got to turn on the motor control itself once.
not yet. Just a moment.
Wait a minute. I'll just get out of the way.
No, it's pretty safe there. It's just when you're close.
All the same.
Okay, so you can run it here. So you can see all of our data, the pitch angle of velocity, all of them are measured, so you can run it now. Yes.
Okay.
Okay.
No.
Yes. And this is the required torque and required current. So the data are sent to that one. So as you can see, if you want to move this one,
Oh,
that pendulum resists, the motion of this one.
I see.
So this is a scaled down two-wheel water wheelchairs, and this mass is considered as a rider of the mass, as a mass of rider. So instead of using the wheels for stabilizing the rider, we use the second pendulum. That is a completely novel controller mechanism. Yeah, and its motion is based on applied by a DC motor. So also according to our calculation in simulation and experimental, the power consumption of this one is much lower than the wheels, and we can use this one and we can increase the battery's life.
So what's simulating the person sitting on it? Is that big weight there? Is it the?
So
is
if
that-
you want to use a bigger weight here,
Yeah.
this is 5 kg, but if you want to use a bigger weight, and because with the rider's mass,
Oh, that does look like the MPU 6050.
that's another thing. So we use
Oh,
it
yes.
for a complementary data, but the main IMU sensor is this one,
Oh, I see.
VN200.
I see.
So if you want to use a higher mass here, we need a more powerful motor there also. So but we didn't have enough budget to buy a very
So you've
powerful
got
motor.
you've got two brushless
Two
D-
brushes,
DC motors in the wheels, and then you've got
Exactly.
what's that one? Another
It's a DC motor
to move the
to
pendulum.
move the thing. So this is exactly what the thing happening. For conventional system that is being used in Segway and two-wheel water wheelchairs, wheels are responsible for motion and stability at the same time. But in our proposed system, wheels only are responsible. Wheels only are responsible for the motion, and
I
the
see.
stability is provided by this pendulum.
I'm just touching it now, and I see
Yeah.
how it's. You see, as I push it in that direction, it's the weight's
So it's
moving.
just try
away.
to stabilize it. It's because it's not really powerful, that motor,
Yes.
because the maximum torque it can provide is up to 2.5 Newton meter. And I'm pretty sure if you want to use a larger scale, if you've got a better motor, we can also decrease the power consumption. And in this situation, we can increase the battery's life. So instead of just charging the wheelchair for each 2 hours, we can charge it, each 4 hours or 5 hours.
That's going to catch though. They're coming down the stairs, isn't it?
Yeah.
That mass.
Yes and no. So I'll just turn it off and I'll show you the range of motion.
Yeah.
Sure.
Because as it swings forward, it actually swings up.
Oh.
Because of the arc of the.
Well,
because of the
that'll be
arc, yeah.
interesting. Okay, let's
So
see.
yeah, it's not really too much of a trip hazard. So it shouldn't impact our ability to climb stairs. Okay. Do you want to hold it and I'll just turn it off just so it doesn't fall over?
for each.
So it's actually at the lowest point when
Yeah.
it's at the bottom.
Oh, I see. So if you were on the stairs, it would be at some weird angle.
Yeah.
Yeah, I was going to be around there somewhere. I see.
Yeah, if you want to pass through the stairs, yeah,
I'm with
exactly.
you. Yeah, because it's just standing vertically. So have you tried sticking it on an incline or anything like that?
No, not yet. Just on the,
It's just
on
the
flat
initial
surface,
test.
Yeah. Yeah, for just using some disturbance applying by our hands, yeah. And we can also test it for the initial condition, living in the 5 or 10 degrees, and see how it works. And it works well, yeah.
And you've got all your data coming out the
And yeah,
mic.
this is the angle measured by that one. You see it's changing. And it's,
Are you using the FPGA in the myRio?
No, not that
Just
one,
the
just
real-time
the
processor.
yeah, and you can see it here. We use a 1 kilohertz frequency. We use this one. The time step, use the time step here.
Is that
Yeah.
for, what's the 1 kilohertz for? For the PWM or something?
No, we are using the maximum frequency of the PWM was 50 hertz.
50 hertz.
So we change it to the UART, yeah.
50 hertz, that's
50
all.
hertz for the
Oh, that's quite
PWM.
low, yeah. I'm
Yeah.
surprised. Yeah, okay, fair
So
enough.
we use it UART, yeah. UART is
Yeah.
much faster than PWM.
So what was the 1 kilohertz then?
1 kilohertz is the frequency of the the loop, the frequency.
Oh, the
for-
bandwidth.
The
of-
bandwidth.
Or the
exactly.
sampling rate.
Exactly.
No, the sampling
Right,
rate.
right.
Both. The main control loop and the IMU frequency.
Frequency.
Are both
both,
sampled at 1
1
kilohertz.
kilohertz.
But the bandwidth of the loop will be much less, maybe 100 hertz or something, or 10 hertz maybe.
We're still stabilizing by watching our strobing.
Yeah.
So we're strobing it every time it loops,
Yeah.
and it's still at that.
That's good.
Yeah, so the idea would be using the 30 kilo mass, 35 kilo mass of the battery as the pendulum, the second
For a
pendulum.
full scale,
Oh,
when
yeah,
we
I'm
have
with
the
you, I'm
80
with
kilogram,
you,
yeah,
yeah.
the mass of the rider is going to be 80 kilogram.
Yeah, I'm
But
with
the
you.
main important thing of this one was the decreasing the power consumption.
Yeah.
This was really important. And we
Yeah.
could get the result and was much
It's
lower.
quite interesting. Thanks very much. It's a
You're
very
welcome.
interesting rig you've got there.
Yeah, we
Thanks.
destroyed a lot of motors on the pendulum.
Yeah. Thank you very
Testing.
much.
It was
Thank you.
a process.